Ladies and gentlemen, recently TryHackMe released the second room of Windows Forensics. In our earlier forensics video, I explained how to proceed Windows Forensics based on the data that we capture from the Windows registry. But today it's going to be a little different. We are not going to use the Windows registry data. Instead, there are some other certain files that you can use to gather some crucial information. And of course, we are going to use the Eric Zimmerman tools once again, but not the same tools. We are going to learn some other different tools. So it's going to be a good learning session. Stay tuned. And why don't we begin now? Windows Forensics 2. Learn about common Windows file systems and forensic artifacts in the file system. Before beginning the forensics, we need to understand the file systems in Windows. There are two types of file systems, FAT file system and NTFS file system. They give brief introduction to those file systems, and also apart from that, there are few other exercises like recovering deleted files, evidence of execution, file and folder knowledge, external USB device forensics. Now let's begin. TryHackMe gave their own machine. I simply spawned that machine and I connected to the TryHackMe VPN. I'll be able to take this machine through RDP. So this specific machine contains all the required tools and artifacts. So let's see the introduction. We learned about Windows forensics in the previous room and practiced extracting forensic artifacts from the Windows registry. We learned about gathering system information, user information, files and folders accessed, programs run, and external devices connected to the system, all from the Windows registry. So our previous exercise was all about extracting data from the Windows registry and doing some forensics. But this exercise we are going to see for other artifacts apart from the Windows registry. So, however, the registry is not the only place where Windows forensic artifacts are present. Exactly. And in this room, we will learn about those other forensic artifacts. Yeah, and we will learn about the different file systems commonly used in Windows and where to look in these file systems, when to look when looking for artifacts. We will identify locations and artifacts to prove evidence of execution, file folder usage or knowledge, and external device usage. We will also cover the basics of recovering deleted files. A very important one. It might be useful to you. We will use Eric Zimmerman's tools. So Eric Zimmerman, a forensic researcher who came up with his own list of tools. These tools are very significant while doing forensic analysis as he came up with a comprehensive list of forensic tools. And again, we are going to use his tools only to carry all these activities and to parse the information present in the artifacts for most of this room. We already used Registry Explorer and Shellback Explorer in the previous room. Hope you remember. For some of the tasks, we will use Autopsy. All right. In this specific room, we are going to use the tool Autopsy as well. So this is just an information. We successfully accomplished it. Let's see and understand what is FAT file system. So here is the definition. A storage device in computer system, for example, a hard disk drive or a USB drive, is just a collection of bits. So they are just describing hard disk and USB device here. To convert these bits into meaningful information, they need to be organized. Once this purpose, computer scientists and engineers have created different file systems that organize the bits in hard drive as per the standard. So file systems are nothing but a specific standard that arranges the bits in a specific order to make a meaningful bits. So the information stored in these bits can be interpreted easily. The file allocation table. FAT means file allocation table. The file allocation table is one of these file systems. It has been the default file system for Microsoft operating system since at least late 1970s. The FAT file systems is very old and ancient file systems and is still in use, though not by default anymore. As the name suggests, the file allocation table creates a table that indexes the location of bits that are allocated to different files. So here is the definition for FAT file system. FAT file system stands for file allocation table. From that name, you can understand it simply has a table that maps the memory location to the specific file. So that is all about the FAT file system, that specific structure. If you are interested in the history of FAT file system, they gave another Wikipedia link to learn more. Data structures of FAT file system. So here they gave some of the data structures of FAT file systems. The first type is clusters. What is clusters? A cluster is the basic storage unit of FAT file system. Each file stored on a storage device can be considered a group of clusters containing bits of information. Every cluster contains bits of information, and a group of clusters makes a file. So that is the definition. And a directory contains information about file identification like file name, starting cluster, and file length. As I said before, a file is made up of group of clusters. So it contains the starting cluster details, file name, and the file length details. So let's see file allocation table further. File allocation table is a linked list of all the clusters. If you have studied the data structures, you might know what is linked list. So there is a diagram to demonstrate the linked list. So file allocation table is a linked list of all the clusters. So you can assume the clusters with the structure of linked list. It contains the status of the clusters and pointer to the next cluster in the chain. So that is how a linked list will look like. So that is the same structure of the file allocation table. In summary, the bits that make up a file are stored in clusters. All the file names on file systems, their starting clusters and their lengths are stored in directories. And the location of each cluster on the disk is stored in the file allocation table. So here is the definition. The location of each cluster on the disk stored in the file allocation table. So that is what the index table. And we can see that we started with a raw disk composed of bits and organized it to define what group of bits refers to what file stored on the disk. All right. So here is the definition for the type of file systems: FAT12, FAT16, FAT32. The FAT file format divides the available disk space into clusters for more straightforward addressing. So this is the standard definition, and the number of these clusters depends on the number of bits used in the address of the cluster. So here is the definition for the FAT12, FAT16, and FAT32. Why we are saying FAT12, FAT16, FAT32? The number of these clusters depends on the number of bits used in the address the cluster. Hence, the different variations of the FAT file systems. FAT was initially developed with 8-bit cluster addressing, and it was called FAT structure. Later, the storage needed to be increased: FAT12, FAT16, FAT32. So before these three FAT systems, there were a FAT system called FAT8. And the last one of them was introduced in 1996. Even the FAT32 is pretty much older. Theoretically, FAT12 is used 12-bit cluster addressing for maximum of 4096 clusters. So here they are calculating the number of clusters in a file. 12-bit cluster is using 4096 clusters, 2 to the power of 12, and FAT16 is using 16-bit cluster addressing for maximum of 655v6 clusters, 2 to the power of 16. In case of FAT32, then the actual bit used to address the clusters are 28. It is not 32, it is 28. You have to keep this in mind. So the maximum number of clusters is actually around this count, and it is 2 to the power of 28. However, not all these clusters are used for file storage. Some are used for administrative purposes and to store the end of the chain of clusters, the unusable parts of the disk, and other such purposes. The following table summarizes the information mentioned above. So, if you don't understand the above paragraph, see the bottom table and you will be able to understand it better. FAT12, FAT16, FAT32, the addressable bits 12, 16, and 28, and 2 to the power of 12, 4096 maximum number of clusters. This is the maximum number of clusters for FAT16 file system, and here is the maximum number of clusters for FAT32. Supported size of clusters. So here is the supported size they gave, and also the maximum volume size they gave: 32 MB, 2 GB, 2 TB, terabyte. So even though the maximum file size for FAT32 is 2 terabyte, Windows limits formatting to only 32 GB. So this is theoretically 2 TB, but Windows limits its formatting to only 32 GB. However, volume sizes formatted on other operating system with larger volume sizes are supported by Windows. Alright. The chances of coming across FAT12 file systems are very rare nowadays, but FAT16 and FAT32 are still in use some places. You are using USB sticks, digital cameras, and other external drives, right? So all these drives are using FAT file system. However, the maximum volume size and maximum file size is 4 GB. I think, FAT16 and FAT32 can only store a file with maximum size of 4 GB, and that is the limiting factor, of course. So reduced their usage. So that is why FAT16 and FAT32 are not being used, widely. So here is the limitation, and also there is another file system to overcome this limitation, the exFAT file system. As the file sizes have grown, especially with high resolution images and videos being supported by newer digital cameras, the maximum file size limit of FAT32 become a substantial limiting factor for camera manufacturers. Though Microsoft had moved on to NTFS file system, they have not preferred the NTFS file system for digital cameras and other USB drives because it was not suitable for digital media devices, as they did not need added security features and overhead that came with NTFS system. Therefore, these manufacturers lobbied Microsoft to create another file system. So that is how Microsoft created the exFAT file system. The exFAT file system is now the default for SD cards larger than 32 GB. So here is the limitation. The limitation we overcame with the exFAT file system. It has also been adopted widely by most manufacturers of digital devices. The exFAT file system supports a cluster size of 4 kilobyte to 32 megabyte. It has maximum file size and maximum volume size of 128 petabyte. It also reduces some of the overheads of FAT file systems to make it lighter and more efficient. It can have maximum of 27 lakhs 96,202 files per directory. So here is the maximum limit in exFAT. So let's try to answer some of the questions. We just read through some theory, and by using that, let's try to answer this. How many addressable bits are there in FAT32 file systems? Here you can see the addressable bits in FAT32 file system. It is 28. So let's try to answer. It is nothing but 28 bits. And what is the maximum file size supported by FAT32 file system? So if you go above, we already came through the size. It is 4 GB. So that is the file size for maximum file size for both FAT16 and FAT32. So that would be our answer, 4 gigabyte. And which file system is used by digital cameras and SD cards? So this is the file system being used in recent sophisticated cameras and digital devices, and the file system is exFAT. Yeah, this is it. We successfully accomplished the first task. So let's move to the next one, NTFS file system. We just came through the FAT file system, the ancient one. Now let's see the NTFS file system, the file system that currently being used in Windows operating system. So here is the definition. As observed in the previous task, the FAT file system is very basic file system. It does the job when it comes to organizing our data, but it offers little more in terms of security, reliability, recovery capabilities. It also has certain limitations when it comes to file and volume sizes. Hence, Microsoft developed a newer file system called New Technology File System. So any Windows machine you can take, this is the file systems currently in place, and add these features. This file system was introduced in 1993 with Windows NT. However, it became mainstream since Windows XP. The NTFS file system resolves many issues present in the FAT file systems and introduces a lot of new features. We will discuss some of the features below. So here are the features of the NTFS file systems. Let's read through. Journaling. What is journaling? The NTFS file systems keeps a log of changes to the metadata in the volume. So this is the line which might be very useful for forensics. The NTFS file systems keeps the log. The log actually records the changes that is happening in the this the changes over the metadata on the system. So this feature helps system to recover from crash or data movement due to defragmentation. Actually, NTFS introduced the journaling feature, the logging feature for crash tackling and data recovery. But these logs could be very useful for forensics analysis as well. So this log is stored in the $log file in the volume's root directory. Hence, NTFS file system is called as a journaling file system. And the next feature of NTFS, access controls. The FAT file system did not have access controls based on the user. This is one of the drawbacks of FAT file system. And the NTFS file system has access controls that define the owner of the file, directory, and the permissions for each user. So NTFS file system, each and every files has its own list of permitted users and a privilege list. And the next feature of NTFS is volume shadow copy. So let's see what it is. The NTFS file systems keeps track of changes made to file using feature called volume shadow copy. So this is the feature used to track the changes. And using this feature, a user can restore the previous file versions for recovery and system restore. Uh, if you see volume shadow copy, it is mainly used for data recovery and restoration, and that is why this specific volume shadow copy is being targeted by ransomware authors. Ransomware attacks often targets the volume shadow copy and erase the volume shadow copy from the victim's device to prevent the victim from restoring the data. Ransomware actors have been noted to delete shadow copies on victims' file system. That's what I said now. And alternate data streams. This is another feature of NTFS file system. So every file must have at least one data stream. A file is a stream of data organized into file system. Alternate data streams is the feature in NTFS that allows files to have multiple streams of data stored in a single file. And Internet Explorer and other browsers use alternate data streams to identify files downloaded from the internet. So here is one of the example. What is the use of alternate data stream? Using the alternate data stream zone identifier. Okay. Malware has also been observed to hide their code in alternate data stream. So here is another crucial line to understand, to know as a security researcher. Now let's move on to the next one, master file table. In earlier we have seen file allocation table in FAT file system. Like that, master files table for NTFS file system. It is like a telephone directory or indexing. Like the file allocation table, there is master file table in NTFS. However, the master file table or MFT is much more extensive than the file allocation table. It is structured database that tracks the objects stored in the volume. Therefore, we can say that the NTFS file system data is organized in the master file table. From the forensics point of view, the following are some of the critical files in master file table. So here they gave the definition for master file table, and at the bottom some of the critical files in the master file table. Let's see what is MFT. $MFT is the first record in the volume boot record, points to the cluster where it is located. MFT stores information about the clusters where all the other objects present on the volumes are located. So $MFT stores the information about the clusters. Clusters simply group of bits, as we discussed in the file system. FAT file system. So this file contains directory of all the file present on the volume. So it is like a directory. And let's see the next one, log file. The log file stores the transactional logging of the file system. It helps maintaining the integrity of the file system in the event of crash. So it records the changes that is being done in the files over the files. And let's see the next one, USN journal. It stands for update sequence number journal. It is present in the $extend record. So keep this in mind. It contains information about all the files that were changed in file systems and the reason for change. It is also called change journal. And let's see the next one, MFT Explorer. So this is one of the Eric Zimmerman tools used to explore the MFT files. And it is available for both command line and GUI version. In this exercise, we will be using the CLI version. That's what they give. And here is the credential for the machine to take the RDP. And they also gave the screenshot of the specific MFT Explorer help screen. So here is the executable and its help screen. If I scroll a little bit further, I can see the example of its usage. You can define the executable name -f to define the specific file to examine, and hyphen CSV, JSON, body, or the whatever the format you prefer, and the file location to store. It stores the output file. So MFT Explorer parses data from the different files created by NTFS file systems like $MFT, $boot, etc. The above screenshot shows the available options for parsing MFT files. For parsing MFT file, we can use the below command. So here is the command to use the MFT Explorer. You can see the structure here. The structure would be very similar for the upcoming tools as well. We will be using the executable name -f to specify the file to examine, and hyphen CSV to store the output in CSV format. So here is the definition. We will be simply changing the executable name in the upcoming tools usage. So just for your information. So you can use the Eric Zimmerman tools inside the Eric Zimmerman tools folder. So they gave simple advisory to find the tools in that specific machine. And you can similarly parse the $boot file. We will provide information about the boot section of the volume. MFT Explorer does not support log file as of now. So here is information. So let's parse the MFT files present on the, this is the specific folder where all the artifacts are present that we need to triage. And let's try to initiate the triaging and answer for these questions. So let's see the question here. Parse the $MFT file placed in this specific triage folder and analyze it. What is the size of the file located at Windows security logs? So this is the question. So if I see the hint, if you are having trouble viewing the CSV file, you can use Easy Viewer from the Eric Zimmerman tools folder. All right. Now let's try to log into that specific machine. Now we are in the desktop folder. I opened the command prompt and I navigated to the desktop folder. If I see the command dir, I can see the list of folders. I need to move into easy tools. So that is the folder. The command is dir to view the. So here is the list of available Eric Zimmerman tools, and I need to use the MFT Explorer. And let's try to, yeah, here is the tool name -f. I need to give, and here I need to triage the file in this specific folder. And what is the question? We need to parse the $MFT file present in this specific folder. And let's try to do that. So here is the one, and hyphen CSV to define the output, and the file name output MFT dot CSV file. So this is the command. We got a warning and it is seeking the administrator privilege. So let's try to copy the same line, and I am opening the same thing again with the admin privilege. CSV output will be saved into the specific folder. Let's see whether we have that file. Actually, it created the file, though it gave the error. It finally created the file. So let's try to open the file with easy viewer. As we have seen in the hint, I'm opening the desktop, and here output mf. Perfect. Now it gave the detailed view. Here we are viewing our CSV sheet. So though we got the CSV sheet, in that output folder, we if you open this file by using any Excel kind of application, you may not able to read it in a proper format. So that is why they gave another tool called Easy Viewer to view these specific files. So if you see these files, we will be able to read the details. It is understandable. So let's try to answer the question by seeing this data. So here is the file name, a column for the file name. So let's see our question. What is the size of the file located at Windows Security Logs? So this is the folder, and we need to find the file which is located in this folder and the size of the file. So let's see that. We need to check for the path here. So here is the path. Control Shift L to put the filter, and sorting that specific path. And you can see the folder name here, dot backward slash Windows Security Logs, and the file name SCE setup log.etl. So that is the file name, that is the path name we need to look. And here we are. We need to find the size for that specific file. So that is the ETL file, and its size is 49152. Here you can see. So that must be the answer. 49152. Yeah, that's the answer. And what is the size of the cluster for volume which the triage was taken? What is the size of the cluster for the volume which triage was taken? Parse the $boot file. If you are having trouble viewing CSV file, you can use easy viewer from the easy. Okay, we need to parse the $boot file now, and let's do the same thing. So I am just minimizing it. This time I need to parse the boot file. All right, now I'm copying this, changing the output file name. Very simple. Now it is done. Let's try to read the same file by using the easy viewer. Desktop, output boot. So here is the file, and only one entry. What is the question? What is the size of the cluster for the volume which, volume from which the triage was taken? The size of the cluster they are asking, and the size of the cluster is nothing but cluster size 4096. So here is our answer, 4096. And before that, let me explain one thing here. Let's move it to the folder, desktop, and here the triage folder. If you see the triage folder, here they give the folder as C, and also within the C they give the entire list of files which was present in the C drive. So what they did is they simply brought all the files that belongs to C drive, and that is the list here they gave. So here you can see the boot file, log file, MFT and all. Just now we looked for boot and MFT and we found some crucial information. So this is how we need to use each and every Eric Zimmerman tools and against each and every valid forensic artifacts to find some certain fruitful information. Okay, now let's resume the operation. So here you can see recovering deleted files. So here is another exercise. For this recovery, we will be using Autopsy, not Eric Zimmerman tool. We are going to use Autopsy. Let's see. The deleted files and data recovery. Understanding the file systems makes it easier to know how files are deleted, recovered, and wiped. So if you want to recover a file, you need to understand the file system and how the file is being deleted. Once the file is deleted, what will happen? You have to understand that specific thing. And as we learned in the previous two tasks, the file system stores the location of a file on the disk in a table or database. When we delete a file from the file system deletes the entries that store the file's location on the disk. And for the file system, the location where the file existed is now available for writing or unallocated. However, the file contents on the disks are still there. So here is the very important point. And as long as they are not overwritten by the file system while copying another file or by the disk firmware while performing maintenance on the disk. So what they are trying to say is, even if you deleted a specific file from a disk, until you overwrite the specific space with another file, the deleted file, the content will be still remains present. So that is what they are trying to explain. And similarly, there is another data on the disk in different unallocated clusters, which can possibly be recovered. To recover this data, we have to understand the file structure of the different file types to identify the specific file through data we see in the hex editor. However, we will not cover that in this room. What we will do is we are going to use a simple technique to overcome that, and we are going to use the tool called Autopsy to achieve. And it is, I mean, is to use a tool that does work with us to identify deleted files in a disk image file. But what is the disk image file? So I mentioned the term disk image in many places when I was explaining the forensics. So what is disk image? They gave the definition here. A disk image file is a file that contains bit by bit copy of a disk drive. It is just a copy of drive disk. A bit by bit copy saves all data in a disk image file, including the metadata in a single file. Thus, while performing forensics, one can make several copies of physical evidence. It is all about taking the physical evidence into storing all the data in this physical evidence in specific file. That is called disk image. And the disk and use them for investigation. This helps in two ways. The original evidence is not contaminated while performing forensics. Uh, we I think by using the disk image, we will not be messing up with the original data on the physical drive. We are taking the copy of data disk image and we are using that image for forensics. That is one of the advantages. The disk image file can be copied to another disk and analyzed without using specialized software. And so these are the two important features of disk image, important advantages. So let's see how to recover the files using Autopsy. With that way, let's see how to recover the deleted files from the disk. We will use Autopsy for recovering deleted files. And there is a specific room for Autopsy learning, but that is a content for another video. So on the attached VM, you will find icon Autopsy on the desktop. So here is the step-by-step approach to open the Autopsy and import the file and do the analysis. So if I go further, I can see some information, how to open the Autopsy and how to pull the file into the application. So here is the thing. Let's see what is the file, what is the disk image that we need to import in the Autopsy. If I scroll further, You can add the required details here. For now, we can click finish to move forward. Autopsy will perform some processing, show the screen. All right. You will see the screen will performing analysis on the disk image. The topmost option, disk image or VM file. So here is the option. We are choosing disk image here. It will ask you to location of the data source. So here we are adding the location as a desktop. So from desktop, it will capture the disk image and provide the location of the data source. So here it is asking the location of the data source, and you will find the disk image named usb.001 on the desktop. So let's see the file. So here is the desktop. I can see the file usb.001. So this is the file we are going to triage. And it is giving a list of ingest modules in Autopsy. We are not going to check any modules now. For this exercise, we are we are simply going to deselect all and continue. So once we did that, we will get the sidebar like this. And once you choose this USB.001, it will give you the list of files. And you can see the X mark here. The X mark is nothing but the files the files that are already deleted from the disk, that is represented in the X mark. We can simply restore this specific file by clicking and by selecting, right clicking the file and choosing the option extract files. It will simply restore that files again. So that is the exercise that we need to carry. Without wasting a time, let's begin. It's seemingly a simple task, so let's try that. So I'm using Autopsy now, an excellent tool for digital forensics. If you get time, you can feel free to install this. It is an open source tool. You can install it anywhere and you can run. And also there are certain minimum system requirements for this Autopsy. Make sure you are fulfilling those requirements. Your system is fulfilling. Perfect. Here is the opening window. So let's create a new case now. And a case name, try hack me, and the base directory I'm keeping it as C, the same thing. And the case number, the name is nothing but here I'm giving my name. It will create the database for the specific case that we're gonna launch. All right, I'm not making any change here, simply pressing next. And here we need to choose the disk image or VM file and clicking next. So here is the data source. We need to add the desktop directory here, and the file usb.001. So that is the file we need to open, and clicking next. So we are going to deselect all. If you select all of these, it will utilize your resource, the CPU resource, and it will take much time to load. Pressing next. So it is loading the specific data into the Autopsy, and yes, we are finishing it up now. Now it loaded all the stuffs, and if I click the plus button here, I can see the USB.001 host. And I'm choosing USB.001. And here you can see the list of files present in the specific USB.001 disk image. And also I can see the files with X mark. These files simply denotes the deleted file. And you can see the flag here, flag directory, flag meta, it is unallocated. So these files are currently in the unallocated memory, which means the files are already deleted from the memory, but it is still present in that because the memory space is still unallocated. So we are going to use this specific, we are going to restore the specific file by simply doing a single step. But before that, let's try to answer the questions that we have. There is another XLSX file that was deleted. What is the full name of that file? So here is the file. Apart from this specific Microsoft Excel sheet, I can see a file name called tryhackme.xlsx. So that must be the answer. Let's try to give .xlsx. That's the answer. And what is the name of the txt file that was deleted from the disk? So let's see what is the txt file. So here is the txt file, tryhackme2. That is the txt file, and it is tryhackme2.txt. All right. Now recover the txt file from the question 2, which was what is the written on that specific file. So now we are going to recover the file, txt file, and before recovering, if I keep my cursor over this file, I can see the content of the file here. thm-4 and 6 -2 -4. That would be the content of the file. But anyway, let's see. Let's try to check the specific option. I'm right clicking and extracting the file by clicking extract file, and I'm storing the same file within the desktop. Yeah, now the file successfully extracted. I'm minimizing it, and here is the file that is restored, and I can see the content here. thm-4 and 6 -2 -4. So let's try to answer. Yeah, here we go. We successfully accomplished this task as well.